Hi everyone. Good morning and good evening. Thanks for joining us today. So today we are going to discuss about the future engineering concepts in the machine learning or deep learning or in the AI field. So like the importance of the future engineering as well, because this is one of the key skills which data scientist or AI developer which is required for him to how to knowing of how to create new features from the limited the futures which is available. Okay, so today we are going to work on three major components. One is from the tabular data. So from the tabular data, how to extract the new features with the photo by considering the 4 to 5 existing features. Along with that, we are going to work on time series data as well, because when we're working in the forecasting use cases, on the time series related use cases, so very important, identifying the new features from the given the time of the data, like considering if you have the gold price, or having the some of the information related to the some specific time period. So knowing about the on the particular time period, what was the day, or what was is the day is in a particular holiday, or it is in a working day, or it is in a weekday, or it is in a kind of seasonal based day. So knowing of the important the futures from the given data as well. So that is we are going to work on the time series based concepts. Along with that, if you are working a few of the use cases like in a unstructured data, where where you need to classify the given the text information, like an unstructured information, to the whether it is in a positive review or negative review or neutral review, or it might be the considering the binary class, if it is in a predicting the outcome is a 1 or 0 based on the given the review of the text information. So so uh, like understanding all about when we are working for the different use case, the data sets, the data structures will be in a different the data style format. So how to extract the new features from the given information. Okay, so as we are the data scientists, okay, we are going to work on three major the component, as I tell you, like in a three type of data feature engineering, like in a tabular data and time series data and unstructured data. Okay, so begin with the structured data or any tabular data. So we are going to work on 12 different features for specific to the tabular data itself. If you have any data, there is a missing values in your data, because see, when as you are working as a data scientist, is in a one of the part or one of the job role, you to collect the data from the various data sources. For example, some organization, the data will be presented into the SQL database, some data will be presented into the Snowflake, some data will be presented into the for the S3 buckets, where you have to collect the data from the different sources, right? Once you collect the data, then you start the step as a data pre-processing or data cleaning part. So where you will be identify, okay, what kind of the steps which can be applied, if there is a missing information in the data. So by applying the some statistical techniques, like in a mean, median, mode, or like in a weighted mean, or if it is in a categorical data, coming up with the different approaches, like that we apply the various steps, right? So in the data pre-processing, there is an additional step we call as a future engineering, because when we apply this future engineering, when we are seeing that our model improvement is not as expected, so we wanted to increase our model performance more, like in a little higher what we see in the existing. So then we come up with the future engineering, right? So identifying the right features from the given data as an input historical data, and if we are wanted to improve any the model performance, then we go back and we add few more the columns, that is what we extract from the future engineering. Then we retrain the model, so that we can get the better accuracy for any model improvement side. Okay, so these are the few important concepts when we are working in the tabular data. One is imputation and encoding and the categorical data, and the binding of the concepts, and doing the scaling and normalization, then follow with the feature extraction and feature interactions. And when you're working with the polynomial features and coming with the text vectorization, log transformation, time-based features like any the particular weekday or like any what was the day, and converting the target variable as an encoding and then extracting the information, then identifying the relevant features with the dimensionality reduction techniques. Okay, where we use a PC, a principal component analysis, or like an LDA techniques for to identifying the right features from the historical data. Okay, let's begin with imputations. Okay, so before we jumping into the other the components, first we'll try to understand how the data sets will be looks in the tabular data, right? So as you see, let me share my Excel file. Yeah, perfect. I think everyone see my the Excel file. Okay, so when we are working for any organization, okay, we get the historical data in the form of CSV or PICL or JSON. It might be the other formats as well. Okay, considering you have the historical data which is having in the CSV file with the futures of like how many features you have, total 9 features. Okay, so from the 9 features, with the help of future engineering, we are going to generate few more columns, like in a 10 more additional columns which you are going to generate. So that's we call as in a future engineering. Okay, along with that, few of the features, few of the columns which is not relevant to the our model analysis as well, so then we eliminate those particular columns as well. So all like in a which columns which is required to analysis, along with that which columns which is not related to the analysis which we are going to eliminate as well. Okay, it's about identifying the right features for the given data. So considering one of the column as age, which you can see the total 1,000 columns, which there is a missing values also which is presented. If you see the total count is 901 only we have, but if I go with the height and weight, total 1,000 features which is there, 1,000 rows which are presented, means there are some rows which are the values are not presented. For example, if you see here itself, the age, okay, for fifth row, and the income, you can see that, and height, weight, credit score, okay, and the target, and the gender, city, and order date. Okay, so this is specifically you consider based on the credit score. Okay, well, and based on the other follow the details, will the if we can we provide the credit card or not, or can we provide the loan or not. This is what the target variable. Will the particular the profile, will it be eligible for the loan or not, or for any credit card or not. Okay, this is the kind of our business use case. Considering this business use case, from these 9 features we are going to extract few more features. Okay, so which when you can see this the data, so all the data which are numerical and non-numerical, that is in a categorical information also which is presented. Okay, so these all steps which we perform before the model training itself. Okay, so coming to here, so one such step is an imputation and encoding and categorical data. So imputation is nothing but as we seen in the just now in the data, out of 1,000 rows, for few of the columns which we have only 900 records only. So how do we handle another 100 records? Because if you considering the the percentage of the data as well, like in 10% of the data which is not presented in your historical data, so how will we handle? So here which need to be come of that, instead of dropping all the 10% of data, so applying some statistical technique which will helpful for you to keep the data, so that which will be helpful for you to model the to train the model as well. So that's where we use the imputation. So filling the missing values with the statistics like mean or median. Okay, so with the help of that we are going to replace the data. Okay, I'm going to show you the practical as well. Then let's understand the concepts what we are going to do now. Okay, and another one is the categorical data. As you see in the Excel file, there are few columns like G and H column which is having a categorical information. So, okay, as we know that machine can understand only the numerical values. If I pass some name based information, will the machines will identify? No, because machines only names numbers, right? So I need to convert these particular features into the numerical features as well. So this is where the categorical concepts which will comes here. If you have some example like in a transform color as in a name, then it will convert it to the binary vector as a 100 or 010, okay, for any names. And coming to the binning and scaling, binning is nothing but you have some age group values, like in a constring. Age is some age column, like in a 0 to 70 years is there. Like in a, based on the historical data, few of the personal profiles where having age is 18, 19, 20, 21, 22, 23, like 40, 44, 46, 36, 37, 68. Okay, so when you're considering the age column, okay, so you, what you are going to do, we are going to split one more column and making that column as a future as a age group. So how will we do that binding? So grouping of similar age group, if considering 18 to 25, giving as a one age group as a child or as an younger, and keeping above 25 to the 40 as an adult group, and keeping 46 to the age group as a 60, keeping as a senior age group. So considering three age group, like in three categorical names, we can make the people who are presented into this particular category, we will drop into the particular age group. So that is what called the binning of the information. Next, scaling and normalization. Consider the credit score itself. Everyone know about the credit score, right, which is having a three digits number. And coming to the age, which is will be having a two digits number, single to like an as a single number or two digits number, right? So considering the two digit number and three digit number, which is in a the it is in a mathematically, when we apply some mean or like in a median also, the numbers will be the difference. So instead of that, bringing up to the equal number, which is having a 0 to 1, so we'll be having the information like this. Okay, so when you do some mean or some statistical by applying some statistical knowledge as well, which will be having a standard values as well when we're considering this information. Okay, that's where we apply the standard like in scaling and normalization technique. So there we will be use minimax scaling and normalization scaling and standard deviation scaling. So various steps will be applied here. Okay, and coming to that, there are some other features called like in a polynomial features as well, where you will be having a like in a considering the age and education, and multiplying with that particular number with the squaring, or like in a taking of the square root. So where we will apply to all the polynomial things. Next, coming to the text vectorization as well, where you have the particular sentence. So consider you have the information like unstructured data, where you see this information, like you will be having the complete unstructured data, each and every comments as an a row which you can consider. So these particular sentence which cannot understand by the human, as we clearly know that. So each and every word there is a one unique number will be presented, right? So this can be handled with the TF-IDF vectorization or text vectorization technique, we can tell that. Okay, there are multiple techniques we have in the future engineering, like an continuous bag of word model, or that is we call as a CBOW, or like an just simple bag of word model, and then TF-ID term frequency and TF-IDF term frequency, inverse document frequency, what to vector, glow vectorization, and universal sentence encoder. There are multiple techniques which will have, okay, for converting unstructured data to the structure like a numerical information. This is where you see that the dog box which is having a information of 111000. Okay, and this particular information will be fed to the model, like, and that will becomes next step. Okay, so and other informations like in a time based futures as well, where you see that like in a considering the time based futures, where you have on the particular day, like in a 2023 on the Jan 1st and the first day, So where the sales is happened 200, okay, 200 sales is happened. So considering there is a one more temperature is in a 20 as well, and in the and one more column we have a is there any holiday and the promo active, is there any promotions which has been provided for the on the particular day as well. So considering here, so if there is any sales is happened for 200 on the particular day, so on the day what was the starting, it is in a Monday or Tuesday or Wednesday or Thursday or Friday. So considering expanding the based on the date, expanding the new columns, okay, on what was the particular day, okay, and whether the particular day is in the starting of the week or ending of the week, okay. Generally more shopping will do on the in a weekend days, right, in weekend days, not the weekdays, okay. That's what we are trying to identify, whether the particular day is in a weekday or weekend day. So all these techniques will be applied on the time based features, okay, based on the given timestamp as well. Create is a weekend hour of the day on which hour which is happened, and month of the particular day, and everything which can be considered, okay. So as I told you, expected year, month, day, hour, and weekday, which will be considered. Okay, and along with that, taking of some window technique as well. On particular day, if it is in a Monday, if I go back last 6 days and what was the particular day and what was the sales is happened. So all this kind of we will apply the window technique, and which we will see that okay how it is happened as well. Lags and windows techniques also, which will tell that in the future, that is we call as a rolling mean or moving average techniques, we say that. So as I told you that event indicator is the particular the naming which we'll call as an in the data science or AI field on the particular day, which is in a holiday or weekend or weekday or is in a special events. Like in sometimes the sales will be increases like in a Black Friday, or it is in a special occasion day, or if it is in a Christmas day, or like in if there is an India, there will be some, or else like in Amazon or these people, they'll keep as in a big day sales is came up for this month of March or summer, or summer sales is will be like, and they will provide you the some kind of the packages where they'll try to attract their customers, right? So that's what will identify the event indicators as well. So and in unstructured data also, which we have seen where we have the for what one sentence where we will have a group of words, okay. So we'll try to identify those words and how many words are presented in the particular the row or like particular commented. For example, if you see this, if I considering this information, so how many of characters are presented. So I will explain. I will take off character count as a one feature and word count as a one more feature, okay. And along with that we can expand like more features as well. So this is where new features which can be discovered, okay, with the help of future engineering, okay. So we'll deep dive into the practical session for three of these categories so that we can have a more understanding. Okay, even when we try to do in the real time. So as we are working, some folks will work on the time series data, so they might have struggle with what kind of the features can be extracted, right? So let's go to the practical session. Okay, let me reshare my notebook. If anyone have any queries, please reach out in the message box so that we can try to answer for your queries as well by end of the session. Let me take the notebook. Just give me a moment. Yeah, I hope everyone see my screen now. Okay, then let me go back and copy the packages. So here As we see the three of CSV files, which is having a structured and unstructured and time series data. Okay, for to read CSV file, we already know that we use the Pandas is a library which will help you helpful to load any kind of file. Like, and if it is an you are holding as a JSON file or pickle file, HTML file, or like an from the XLX file, any type of file, may all the files which can be which can able to load with the Pandas package. Okay, that's where we have learned with the Pandas technique as well. Uh, I hope someone is unmuted their mic. Please, you can mute yourself so that we can have a clear information. So yeah, so these are the future like in a packages which we are going to utilize for our future engineering purpose. Okay, so everyone knows how to install the packages in Python as well, like by using pip space install and the package name. Okay, so just we try like if the package is already installed, we can see that requirement is already satisfied. If not, the package will be installed in your machine. Okay, so let's jump into that. Let's rerun. So my packages is already installed, so I can see that like there is no issue. Okay, I'm going to load my data. Okay, so here you can see that the information which we just see in our Excel file, like an age, income, height, weight, credit score, and target, and gender, city, and order date. Okay, even you can see that df dot shape, which is having 9 columns, 1,000 rows we have. Okay, so general we already know that if I keep df dot info, which we can get to know how many of like any clear information, how many of which column, number of rows are available. As you see that for age column, total 900 values only presented, which is having in the data type as a float. And income, height, weight, credit score, and target, we have city and order date, we have total 1,000 variables, total 1,000 columns. Okay, 1,000 rows, which is having there is no missing values in this particular columns. And gender, we see that there are 50 rows that the values are not updated in our input data. So this is where we are going to come up with the picture. Okay, so coming to here, first step, as I told you, that the imputation is nothing but replacing the missing value with the statistical values. Okay, so here statistic technique which we are going to use median or mean or mode or weighted mean. Okay, so based on this particular four features which can be replaced wherever we don't have the values in your input data. As we see here, age and gender, we are facing the missing value. See, the count is less right here, so that's why we have taken off only 2 columns and we are applying the imputer technique. Okay, let's see. We have run successfully, and you can see that now df.shape, df.info, which you can say that all values which is replaced with the statistical value. Okay, so which you can see that this is the imputer technique which will apply the strategies of mean. Okay, yeah. So now, even if you wanted to see that, like, and you can just see that what type of value we have replaced here. You can just keep it with that female. Female is nothing but the most of the time which is the data is presented in the female. So that's where wherever the gender which missing value is presented, we have replaced with the female. Okay, and even you can do with the age as well. Okay, 0.36 is the like in a means which is already the values which is already normalized. That's why we are saying 0.36. Don't be confused, like an age will be having 32, 31, 33, right? But they have already they already have converted these values to the normalization. That's why we are seeing the single digit value. Okay, so here you don't need to apply any scaling and normalization technique. That's what I wanted to convey to people. Okay, let's jump into that. Okay, in our data, in our data we have a categorical values, right, where gender and city. So these two values which we are going to convert to the numerical value. Still we have not came into the future engineering. These are all the steps into the future engineering only. Later we are going to implement a few more features. Okay, from here. So the all the future engineering which can be we can generate all the futures only with the when our data we have a numerical values, then only we can create a new more features, okay, with the statistical based. Now that's why we are converting all the existing columns to the numerical field information. Now again you can see it here.
Hello.
Yeah, gender encoded, okay, which is also done as a gender part of that. Okay, next we'll see that for city column as well. Here itself we can keep. You can see that I have created for the city as well. So all the you can see that number of cities are presented in here as well. So wherever, like in total, 4 unique cities are presented: Chicago, Houston, and Los Angeles, and New York. Okay, so 4 columns which has created. This is where the future engineer will be coming up. Okay, total now few more the columns which are added here. Okay, now as a part I told you that the binding method. Okay, so binding method here, what we are doing, we are considering the age group are from the 0 to 25, 45 to 65, and 100. Then we are making of that, which you can see that. Okay, so all the binding age features also which is converted now. So next is scaling. Okay, next is scaling we are going to do. I'm just going to show you how it will be utilized. Okay, so this is a minimax scaler we are using. Even you can use the standard scaler as well, which will be available in the Scikit-learn package. Okay, like let's see. Yeah, income also it has been scaled now. Now another the future is like in the date, order in a month. So now considering as a order as a date. Okay, so if 2023 January month and the first Jan we can say that. Okay, on what is this particular week, okay, on what is the particular day, everything which we are going to see now. Okay, so which month it will comes and everything, so we can see order it is in a first month or second month, third month or fourth month, and along with that the what was a particular day of the week as well, like in a that is a starting of the first day, or like in a middle of the day, or like in a week we like in a the Saturday or Sunday. It's all about 0 to 6. Okay, which you can see that order day of the week as well. And one more feature also we are creating here, body mass index as well. So which you can see that body mass index based on the weight and height, we can get the body mass index as well. Okay, which is we have generated now. Okay, and coming to the polynomial features as well. Okay, so here you can see that total now you see that 23 columns is generated. The initial of the data when we loaded total it's 9 columns. Now you can see that total 23 columns is which is came. Okay, so that is where the polynomial features also which we have taken for credit score and income as well. Okay, let's apply log transformation as well. So this, I'm not saying that these are all techniques which need to be applied in the future engineering, but as for your requirement, you have to choose which feature will be helpful for your analysis. Okay, so here in this session we are learning what are the different strategies will be available, what are the different future engineering steps will be available which we are learning here. Okay, it's all about you know selecting from the out of 12, selecting the which are relevant to for your analysis, which you need to pick up and which we need to do it in that. Okay, so which you can see that log of credit score also which is we have taken now. And another one is the weekend, or like it is in a weekend or it's in a weekday, which we are seeing that. Yeah, is a weekend or weekday. Okay, if it is in a greater than or equal to 5 means 6, we can consider that it is in a 5 or 6. 0 to from 0 we are considering, right, a total 7 days, 7 days will be presented in the week, right? So based on that it is in a weekend day sale or it is in a weekday sale which we are considering. That is a true or false as a Boolean factor. Next, targeting encoding as well. City targeting mean as well. Like, and you can see that in from which city we got off more sales as well, which we can get it from this city target as well. Okay, so that's why this why I, as I told you in the beginning as well, before we are making any future engineering column, before trying to make any new columns, first we'll have to convert all the existing columns to be the numerical values. So from there we can apply the statistical technique, and through that we can get the new features. That's where we got the city target mean as well. So another one is dimensionality reduction technique as well. From here also you can get the more features as well. Okay, so total 26 columns which is came. So you can see now df.shape, so which is having total 26 columns. So we started with the 9 features, but by when we arrive in the before the model training steps, look, total we have 26 columns which we have created. So this is how we do the future engineering for the structured data information or tabular data, which you can say that. Okay, so just to recap ourselves, we have loaded our data, okay, which is having the tabular data. So where we are applying, the first step is the imputations, where we are trying to handle the missing values, and then we follow with the converting a textual information to the numerical values. That is what a label encoding which we have applied here for the gender and the city columns. Then follow with that we have used the binding methodology, where we are creating the group bins, like in a group of inform numbers which we are considering, and we are a group of numbers we are calling as a one unique name. So like that we are trying to create a one more column as with the help of binding methodology. Then we are applying the scaling and normalization technique, where we can bring down the two or three digit numbers which can be bring to the single digit number. That's where we are applying the minimax scalar. Then following with the future extraction of the if we have some date order date as a date future date column, from the date we are trying to extract what was the month and what was the day of the particular week. Okay, from the given order date we are trying to extract the information. Then we are extracting the following information as well: BMI, body mass index as well, based on the person weight and height information. We are creating this future as well. Then going with the polynomial features for the income, and where we are working with the banking sectors, the polynomial features will be really helpful for you to creating the new features as well. Then creating the log based approaches as well, log transformation also will be helpful for your banking based use cases data sets. And even ease weekend, so we are creating the new more features, whether the particular day of the week which is in a weekend or weekday. So we wanted to know the sales, because most of the sales which will be happen in the weekend, right? So that's what we wanted to say, whether this graph which is going to be happen with the weekday or weekend day. So then we are taking off the and which city we are trying to get the more sales. So that's what one more the future engineering, where we are considering as a city target mean. Then follow with the PCA, where we are trying to identify that which features are more for providing to our model analysis more insight. So that's where we are applying the principal component analysis as well. So this is about the tabular data for future engineering. Okay, I think I'm just passing for a moment. If anyone have a queries, please feel free to ask me before I jump into the time series based features as well.
So for the age that you had did
Mhm.
binning, right?
Yes,
Based upon the, so here the age is not in the, it's not ranging from like 0 to some 40 or
right.
50. It's like in negative and some positive value. So I think that's the where we are getting only when it is greater than 0, it's giving young, and when it is not in the case, it's giving NAN because
Yes,
it's not able to categorize them into bins.
exactly. See, this is some synthetic data which I have created. But
Okay.
when you're working on that in the real time scenarios, where you see the age group, like for example, I will show you the few data sets. Okay, where yeah, perfect. Let me reshare my screen. Okay, for few of the data, where you will be having the clear patient age details. Can you see my screen?
Yes.
Perfect. Yeah, where you see that, because the data which have taken, which is already normalized, like a scale, normalized data. Okay, so that's
Okay.
why where we are seeing these digits, which has been converted to the single digits. Okay, means like in
Okay.
the form of within the 0 to 1 range, which will be there, like below the 10 only. Okay, so
Okay.
that's why we are seeing that. So generally, when you get the receive, based on the some of the data, we cannot not show, right? So sometimes they
Yeah.
will
Yeah.
give directly this value, sir, or else this age value also, which will be extracted from the patient date of birth, where we will have a month, date and year, right? From there we are going to calculate the what would be the right age for the patient as well. Okay,
Okay.
which you can see that.
Yeah.
So,
Actually,
yeah.
there is one more doubt. So in
Mhm.
the date, you had applied filling, right? So
Yes.
you filled it using the mean.
Hmm.
So it is already normalized, right? Like you said, it's already normalized. So
Normalized. Yeah.
yes. So if I fill the NAs with the mean or some median
Mhm.
and normalize it, is it better, or first I have to do normalization and then fill it, which is better?
No, no, no. Before normalization, doing of the mean will be better actually. Okay, because
Okay.
that's where the
Okay.
originality of the data will be there. And I
Okay.
will suggest you going with the simple mean and median mode will won't be work some cases, where you see
Okay.
that considering when you're working with the like in a different age group of peoples, like in a providing the loan. Okay, considering 18 to 25, if you're considering the age group, the mean will be that in the form of 20 to 23. If I club from 18 to 60 years, the mean of the value will be 40 to 45. So
Okay.
considering
I guess.
as a person of the age 40, okay, he might be already working, he might be earning some good amount. But considering for 18 to
Okay.
25, it is in a very less, right? Very few people will earn to that particular the number which the people who is earning 40 age group. So here we need to go with the strategy, like in a how considering the mean from the specific age group based on the bin level as well. Okay.
Yes. Yes. Okay.
Yeah, thanks. Let's jump into the another one, time series, to where you will get a more detailed features for time series use cases as well. Let me reshare my screen. Yeah, wonderful. Cool. Okay, let's load for another data. Okay, so here we'll see the time series data. Okay, where you will be having the 5 columns as we see in the 2 minutes ago, like in the CSV file, right? Where we have the is already and the promo active on the particular day, how much sales is happened, and the temperature also. People are interesting about why the temperature column is given for the sales data, right? See, if there is an if you considering for the summer itself, like, and if there is too much heat, where the people will go for shopping to do that, right? If you have some personal vehicle, like in where you can go with the vehicle, even you sometimes you won't prefer for that to go outside of the the things to do the shopping as well, right? But that's where the temperature also which they have been given that. So to understand, and from there in what temperature value if it is there, like in a it is in a good to have any more sales as well. So that's where the temperature is given. Let's go with that more in detail. So first is, let's understand, is there any missing values are available in our data? Okay, info. Yeah, which you can see that there are total 365 records, which is there is no missing values in our particular data sets, which we are clear. And coming to the data type, if you see that the three of the four of the columns, the sales temperature is already proactive, which are the numerical columns, which is having float 64 and integer 64. Coming to the date column, which is having the object, which we won't have the date time column as a data type. Okay, so for that what we do, because when you're working with the time series data, the first step we have to see that how our data types of the each and every columns, whether it is an object or it is in a time series data or date time data type, or what type of the data type which is presented here. Now if you see here, I'm converting to the particular date column as a date type. Okay, where you can see that. Okay, so which I have taken here, because I just wanted to see that like in a on particular day how much sales is happening here, right? So that's why here, one second, it's loading this step. Let's me restart actually. Something has happened. Let me reload the package. Here, just go. Yeah, it is came. Yeah, it is came. Yeah, it's just like I'm working on the Amazon, the SageMaker Studio. So because of internet is reconnected, so that the kernel which has died. So that's where I restarted myself the kernel. So you can see that now. Okay, total 4 columns and everything which I have kept it. The date column as an index here. Okay, this is where the initial steps begins for the persons who are working in the forecasting use cases or time series based use cases. Okay, many of them already know that for time series models we will use like arima, sarima, and profit. Okay, so these are the popular models, and sometimes we use with the neural network as an rnn and lstm based as well for time series problems. Okay, before we use those models, so first we have to apply the future engineering techniques, right? How the what data will be like with these futures, we cannot tell directly. Okay, so for next month or for next quarter, so we are going to generate the revenue of $300 million or $200 million. We cannot tell that as an assurance, right? To tell them more, the kind of like an accurately results, so we need to have a right futures on which day also which we are going to get the sales as well. As I'm saying that for in a quarter we are going to generate as a $300 million. But if I wanted to see what will be the next week of the sales, or what will be the next Thursday of the sales, or what will be the next Friday of the sales, on which day I'm going to get more sale for the next quarter, if I wanted to see, that's where we wanted to split more the futures into the more number of futures. Okay, with the help of the time series based techniques. Okay, here the Pandas is a very good package where it will for making of the new futures for the time series related issues as well. So let's jump into here. First, visualize our data, how our sales has been happening throughout the with the timeline, which you see the monthly basis. You can see that, and you are by seeing of this data itself for the month of May to in the month of August, the sales value is very low. But if you see that January to April and September to December, the sales are very high, right? So if you see that this is the pattern, most of the sales we are dropping here in the summer season, right? In the summer season we can see that the sales are very dropping, because that's why they have taken the temperature as well, where the temperature is low, so the sales are little high. Okay, the sales are high. So now we are going to identify that with the various features as well. Okay, let's jump into that with the date time based features. Okay, so for the daytime based features, I'm going to take what was the day of the week. Okay, this is a Monday or Tuesday or Wednesday, Thursday. Along with that, based on the weekday, I'm going to create one more feature. So what was the particular day? It's a weekday or it's a weekend. Okay, and what is the month of the day? Okay, month of the date, and what was the quarter of the day? Okay, everything which we are going to generate now. So total 4 more features which you are generating. You can see that. So what is the day of the week? You can see that. And 2023-01-01, that is a Saturday or Sunday, which I can say that. I can damn sure. So let's see, because whether the day of the week which is given, right, the 6th, how it is given, we wanted to see, right? So you can see that Sunday, which is clearly. Okay, that's why it is they given as a day of the week 6. when the day will starts from the 0 as a Monday, and the day will be end as a 6 as a Sunday. Okay, so which you can see this way, you can see that is weekend, that is a weekend, right, which is given as a true here because it is a 6, clearly seeing that the particular day was a Sunday as well. Okay, and this is a month as well, this is a Jan is a first month, right, that is where we are seeing the first month. So as we see the quarter level, Jan, Feb, March are the first quarter, and the second quarter will be the April, May, June. So you can see that like total 4 quarters which has been divided. So on the first row we can see that first quarter as well. So here you can see the 12th month as a fourth quarter as well. Okay, so like that 4 rows which we have created. So this is where which you need to create, like what was the day of week, what was a week, whether it is in a weekend or it is a which month or which quarter as well. Okay, then coming to the lag features. Okay, now what we do, okay, if as I'm seeing here, so if I'm considering this is for the Jan 1st and 2023, if I see that this is the sales. Okay, if I'm shifting to the 1 day, okay, that is where the sales shifting to the 1 day and 7 days, what would be the my sales will be happened. Okay, so this is where one value we leave, and the previous the sales whatever which is happened, that will be added to the next day, that is where the lag went. And lag 7 also what will happen, so on the Jan 1st the sales which has happened, we are going to take on the Jan 8, that is a lag 7 shifting of the 1 week above. Okay, so this is where we create the new features as well. Now another technique is the rolling window feature. Yeah, similarly here, what was the sales happened for previously, if I considering rolling mean as a 7, okay, as a standard deviation as well. So for 7 days of the sales we will take, and then we are going to create the one value, that is what the rolling mean 7 means, total for 1 week how much of the sales is happened, that is what we are going to add it in the rolling mean 7. Okay, which you see that first 6 days, the you can keep deep ed as a 10, so that you can see that what is a rolling 7. You can see here rolling mean means first 6 values are empty because seventh value which is added here 201. Okay, how it is happened, this is the average of the from the first to 6, average of the from the day 1 to day 6, like in a Jan 6. So that's the seventh value which is added here 201. Okay, when I'm taking the standard deviation which is coming as a 16, this is how the rolling mean will be happen calculated here. So coming to the next features, and here we are going to expand the window feature as a mean as well. Okay, so basically, in the time series based use cases, we go with the day of the week is weekend and rolling mean and average rolling mean and rolling standard deviation. And if I'm going to take the lag based feature, okay, so what the previous of the sales will be the new column for the sales of the lag one feature. Okay, so like we are going to take of the expanding the mean value by taking of the average as well. Okay, from the sales. Next, sales difference also, this is to identify the kind of difference of the seasonal based how the sales is happen. So that's where we are seeing the sales difference. Okay, okay, sometimes why you see this 27 and minus 44 and 23, how you are saying that, like because how much of the percent, the first day the sales is happened 214, but when you see that the second day the sales is happened 203 only, the expanded meaning, if you say that, that is where the minus 44 which is came, because in all days we cannot tell that the the profit will be the same or will be increases, right? Sometimes the profit will be low as well, the sales will be low as well. Sometimes we sell in a day, it's like considering the $10,000, and the next day we might sell sold only the 6,000 sales only, $6,000 sales only. We cannot tell that, right? So that's where the sales expanding mean the difference we are seeing. Okay, the positive you can consider it is continuing on the previous day and the same day, which is sales is increased compared to the last day. Okay, the negative
So,
values which are
so it's
indicating,
taking the average per day, daily
yes,
basis,
daily basis
increasing order.
exactly,
Okay.
exactly. So next is the minimax scaling as well, which we can see that one of the future minimax. And then we are seeing the holiday, the particular, the promo active which we are providing, whether the promo is providing for any holiday purpose, because sometimes the promos will be provided on this particular big day sale. We are offering these promos, right, like in 100% discount for these particular items, or 25% discount on these particular electronic items which they will be provided. This is where we have created the, if we are releasing this promo, so this promo is having the holiday or it is in a non-holiday. Okay, that is where we are saying. And next we are seeing that if any null values we have, we are replacing, dropping, and we are seeing that off. Okay, so this is where the finally the time features which will come up majorly, like in a rolling mean and standard deviation, rolling window technique, as which I can tell that it is in a mean or standard deviation, as per the use case, or as per when you're working with the business use case, we can decide it going with the mean is better or standard deviation. Okay, so but having the knowledge both, it will be helpful for you as well. Okay, so this is how we can use for time series based use cases as well. Even you can sometimes see you have this all is already the column you have, sometimes this particular column will won't present. So in pandas you have one good object as an the library, where the particular day is in a holiday or it is an non-holiday as well, where you will be having the complete US calendar holiday list, or you can customize your the holiday list as well, because European they might be the different holidays. If you are considering for Indian, they might be the different days are the holidays, right? So those holidays also which can be added here as for your creating the is holiday column as well. Okay, and even you can make Saturday or Sunday or like in everything which you can add it as well. Okay, this is how we can say that the time series based futures. Let's jump into the unstructured futures quickly. So okay, so here this is the unstructured data. So sometimes see, we cannot tell that like in all ways we work on only the structural data, right? Sometimes we need to work on the mailboxes as well. Sometimes your manager will come up and they will give you some message bodies like as a mail mail data. So where you need to come up with that to classify these particular mails related to the technical conversation or non-technical conversation, which you need to identify the classification. So where you will be having or it's in a kind of sales product as well if you consider multi-classification. So based on the conversation, based on the words which has been used in the mail body, so you have to figure out if this particular mail belongs to the technical or non-technical or like in a sales based approach. Okay, so basically this is how it will be available. Considering this is the information for an e-commerce industry, where you have the different set of the category where the people provided the comments for the particular items which has purchased, and the rating also which you can see that whether this is belongs to electronic or household or toys as well. Okay, some people they given the review as an F5, and some where the people has felt happy about purchasing that particular product, and people who are not happy on that particular products, they given up the rating as a low as a one, or like in a considering two or three as in a low version as well. Okay, let's jumping into that. If you're getting of these kind of data, how will we handle? Okay, as I told you, the first initial step is for doing of any information we need to convert to the numerical features, right? So that's why we are converting to the numerical features, and along with that two more features also we are adding here. So here you can see that first, I've converted to the categorical information. Then I've added two more features as a text length and word count. You can see that few of the customers where they have used 51 characters. Okay, that's what text length total 51 characters which they have used. Okay, for this particular the review, and sometimes the people do the very short review as well, right? Where you can see the 13 and 40, and you can see the minimum word count minimum 4, 5, 6 they are using. Even if you see that, if you take the count of that word count, See, most of our reviews, max words are 10 words. Okay, minimum words, you can see that total minimum words itself 4 words they have used. Okay, so considering 4 words means nothing but like in a the complete word. Okay, sometimes the characters will be different, right? So here we see that.
We are unable to see the screen. We are just seeing the mean screen, rolling mean,
Is
that
it?
one. Yeah.
Oh, one
Yes,
second, let me.
yes.
Oh, okay, I'm so sorry. Yeah, just give me a moment. How about now?
The same screen.
Same screen, right? Okay, just give me a moment. Oh, I'm so sorry. Yeah, I'm just in the another notebook which is there. So I'm explaining that one. Okay. So now, how about now? We can see that, right?
Yes.
Okay. This is the data as I'm loaded here. Okay, which you can see that as of I told you that rating will be 5, 4, 3, 2, 1, and the category is an household toys. Okay. I will add few more steps which I have to discuss just now so that we can have it clearly. Okay. Yeah, which you can see that total before I do the processing. First, I've done the category as encoded, like in where the text column, which is the category column, which I've taken as a unique values, like in the numbers, and then follow with that, I've created the text length and word count based on the text column. Okay, so sometimes the people, as I told you, that people will use their as for how they felt about the particular product, right, when they purchased. So they use, based on they expression, they will explain, they will explore express in the particular platform. Okay, sometimes they use 4 words or 5 words, sometimes they use the complete, like the bigger information they will write in the particular platform, right? So as we see here, df text, okay, for the word count. Okay, max, if I see, so in our data set, I see maximum the words which as used by the users are 10 words. Okay. And we can see the minimum as well. Minimum count of the text is 4 words. Okay. Now, if you see the character based information, that is a text length, which you can see that total 51 characters they have used for making of one story. Okay. And minimum is 32, max is 51. Okay. So, but as you see, so just don't consider only with the 51 characters will be sufficient, that is only the final count. But when you're working with the real time data, where you are going to see that 4,000 characters for one conversation will be there, or like in a 30,000 conversations will be there. So in upcoming sessions where we are going to introduce the live data sets of the where we have worked on the customer complaints use cases as well, where you see that 30,000 of the characters also which is presented in the one complaint as well. Okay, where the customers will detailed, they explain the particular issue as well. Okay, and like at least thousands of words will be there, 1,000 to 2,000 words also will be there. So you are going to work with a larger number of volume as well. But as you see here, this is the minimum information. Okay, but this is what we initially identify, because we wanted to see that, right, how these complaints are distributed. Okay, number of words which the customers are using as well. So based on that, we can reduce and we can apply the various strategies as well. Okay, just a minute. Now the polarity, that is the sentiment futures, how our sentiment futures which is available. So these packages will be available in the NLP itself, like in a NLP, like in a you can download the NLTK toolkit, where you will be having the text block and various stop words removal. And yesterday, my one of my folk, like in a fellow, which is explained you complete like an EDA techniques as well in the text mining, right? So where you are using text blob services as well. So similarly, we are using text blob services to identify the polarity of the thing as well. Polarity means that is the rating which is an how sentimentally which is available as well. Okay, and coming to that, another feature for unstructured data, you will be using counter vectorizer. As I told you that,
You know
bagger
I'm
for
faster.
model.
Venkatesh, I think we are seeing another screen. We're not seeing the right screen.
Oh, I'm so sorry. How about now?
Yes.
Okay, okay. So another the techniques is that the bag of word model. So where bag of word model, there are like in converting the text into the numerical features as well. Like in I will explain expand and I will show you. So which you can see that. Okay. So each and every word which you see that as a one column, okay, when you are using the counter vectorizer as a technique, there are multiple techniques which we use when you're working with the real time based on the use case, the timeline. Sometimes you go with the general TF-IDF vector or TF vectorization, or like going with the neural network concepts of what to vector or global vectorization technique that's we call as a globe and universal sentence encoder. And if you are working with the Gen AI, where you are going to use with the text embedding ADA 002, if you're going working with the Azure Chart OpenAI services, like in a small or large, or if you're working with the Amazon Bedrock based services, you are going to use the Amazon Titan embeddings, where you will be converting this particular text information to the numerical words. Okay, so as you see that this particular, if you considering the worst experience ever completely, so you can see that these all the features will be having a one word will be having a one column here. So if that word will presented in this particular row, so there it will make as a one. If that word is not presented in the row, it will make as a zero here. Okay, that's what we see the 10001 concepts here. Okay, the other step is that where if you are wanted to explore with the TF-IDF vectorization, so here you can use the TF-IDF vectorization as well, which you can see, we can see that the difference as well. So here TF-IDF vectorization, instead of 0 to 1 range, where you can see the 0.4796 or zero point 0.0, if the word is not the weighted, okay, if the word is not as important for the analysis of the particular sentence, then we can get the lower score as a zero. You can say that if the word which is having the importance, we can see in the range of 0 to 1, the higher the score you can consider the particular word which is need to be considered very highly, okay, for our analysis purposes, which you can see the 61 37 56 and all the informations, okay, 34, which the word which is having little importance, where you see the 30 34 as in a range here. Okay, next is that the custom keyword presence as well, where you can see that whether the word is in a quality or like in how this word which is presented as well as a quality or as a supportive. Okay, quality means for making any sentence considering for expressing your like in a the happiness or like in a sadness, it's all about the kind of the words which you are using in the input text, right? The worst experience ever completely disappointed, the worst, the is nothing but the stop words which is not required for us, right? So here worst and experience which are highly important, where worst is nothing but you're completely feeling a sadness, you're completely having a negative information on the particular information, right? So this is where the word which we are trying to identify, which is in a quality word or supportive word as well. Experience is a supportive word, which I can say that worst is a quality word to understand whether the person's expressions of the particular items. Okay, so this is about the unstructured data, where you have seen here, three type of methodologies to understand whenever you're working in the different use case scenarios. Okay, so if you have any features, like by end of the sessions, which we can discuss more detail for the future engineering side. And thanks once again. And I'm handling the session to my another folk,
Yeah,
Pranay.
hi Venkatesh.
Yeah,
Like, yeah, you said you had did some feature engineering, right? In the end,
yes.
what if I
Mhm,
want to categorize that review as bad, good, bad, something like based on the comments that they give? If I want to
mhm,
categorize them into like something good review or a bad review,
mhm,
like
mhm.
how do we do that?
Yeah, see, if you are beginning of the AI program, okay, I highly suggest you to go with the logistic regression, where you can explore. And because to be classifying those words, based on those words we already have the label data, so we can get that if the similar words, with that we can do that, okay, with the help of TF-IDF technique. But this classification which has to happen more contextually, because sometimes the people use in a wonderful and happy, okay, wonderful and happy, where you are telling expressing on more on that, more in detail, in wonderful means you are giving of more about expressions, right, comparing to the good and wonderful. So in a good is nothing but okay, I just felt happy, okay, and just you're saying that okay, okay, but when you're saying using the word as in a wonderful, then you have liked more and more, right? So this
క్లాస్
is where
అటెండ్
the
బయట అయిపోతుంది ఎక్స్ప్లెనేషన్
sorry,
చేద్దాము మళ్ళీ ఇద్దాం మాట్లాడితే నిక్కి మాట్లాడాడు
can you unmute yourself, Masadi? I don't know about. Okay. Okay. Then you can go with the BERT as well. Bidirectional encoder represent transformers. That is in the transformer method, where you can do the contextually, where you can do the sentiment analysis. Okay. I highly suggest first you do with the logistic regression with the basic machine learning. Then you can jump with the transformers, where you can get the more accurate results for the sentiment analysis, where the sentence can be identified with the contextually based.
Okay, thank you, Venkatesh. Thank you.
Yeah. Thanks, Kaushik. Uh,
And where can I get the sample data for practicing these files?
See, we are from last 7 years, where I've created all these data sets from the beginning. So
Okay.
with the real time data sets also, which we pull up, and some some sample records, like 1,000, 2,000
Yeah.
records, and we show them in the demonstrations actually.
Okay. For practicing, where can I get those files? Where can
Our
I
team
download?
will,
Is there
no,
any
our
website
team
is
will,
there or
no, we have the particular portal where our people will provide you all these data sets. Like we have the Git repo where you will get that. Okay, we will provide you the access for you to download and to see all these notebooks as
okay. I mean,
well.
as
Okay.
part of interviews, they will ask, is it scenario based or how they will ask? Like right now, you explained three types of
Mm-hmm.
series, right? Like, I mean, which point they will concentrate more and what exactly I need to prepare for interview, like work,
I
work.
got it. I got. See, I
Yeah.
will tell you. See, it's all about if you already have working for some companies where you have experience. Okay, with the NLP or based unstructured information only. If you considering that point, better you go with the unstructured information where have connected the mail bodies information. In the mail bodies information where have applied this the text word length and characters length, and applied the TF-IDF vectorizations. For this is the one of the data set which I worked. Okay, sometimes
Okay.
you may get the chance to work on the time series based models. So this is where you have to take up one or two projects completely end to end. This will be in the coming days, where my teams are going to train you as well with the taking of the complete concepts as a business use case. So understanding of the business use case problem, then what kind of the approaches which we need to be follow, and along with that, okay, what type of the models which can be utilized. Okay, these particular projects which you can keep it to your resume, and then you can tell that these are the projects which I worked. Okay, this is where the interviewer will be it shows more interest on you. Okay, telling of taken off some git repo from Kaggle or somewhere, so it won't be helpful. Where when you're telling of that where I've worked in the real time with the industry's persons, this is where the people shows interest on your profile, right?
Okay.
Okay, it's all about taking of one project. You tell that this is what the project which I've done. Okay, it might be the
Okay.
structured, unstructured times, it might be anything. Don't worry about that. People will see
Yeah.
whether
Okay.
it's a real time project or not. As for my experience from the last 15 years which I'm saying you, please don't take it on
Yeah.
the
Okay.
another way.
Okay.
Okay.
Thank you.
Thanks. Thank you. Uh, Pranay, I'm handing the session to you. Are you ready?
Yeah, hi. Hi, sir. Yeah, ready.
Thanks, Pranay.
So,
Yeah.
mhm. Yeah, hi everyone. So, can you see my screen? Hello, can you hear me? And can someone confirm
Yeah,
that?
yeah,
Yes,
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 we can
yes.
see
Anil,
you.
we
Yeah,
can. Go ahead.
yeah, yeah, sure. So today, I will be explaining you about regular expressions. Uh, as we are working in generative AI, so it is extremely important to work with text data. So we know that NumPy, Pandas is used for like data manipulation or working with data and cleaning the data, right? So and NumPy is for like mathematical expressions like matrix multiplications and everything. So right now, in order to work with the like textual data and the clean the data, extract the relevant fields or extract relevant information from the textual, like if you have like bigger text comments or something. So it is you have to understand regular expressions. So most of the generative AI, so most of the generative AI like data sets which you work, so you use textual data. So in order to find the sorry. So in order to find the patterns matching, in order to find in an efficient way, in a programmatic way, so you have to use regular expressions. And most of them, I think, know regular expressions, but it is extremely important to understand how those works. And if you want to do any kind of like input validation, or if you want to do any kind of scripting as well in terms of using a textual data, so you have to use regular expressions. So in order to work with the regular expression, so Python already has a regular expressions inbuilt. So if your Python version doesn't have, you can just import like you can press this comment import R. So for example, if you can see here in the first one, so what I'm doing here. So first, for example, if you want to search, match, or find the span, for example, there is a text. If here I'm highlighting it, this is the text we have. The quick brown fox jumps over the lazy dog. And if you want to find a pattern, for example, if you want to find the pattern brown, brown from the text, and if you want to find the pattern, along with that, you also want to find the index from where to where the brown is found in the text. And if you want to do that, so if I press see here, so re dot match. So what I'm doing, I'm trying to find out the pattern, and I'm assigning a variable match where I am searching through the pattern in the text, searching for the pattern in the text here. So in that way, so you are able to print the match. If you can see here, so brown is being matched and the span is 10 to 15. So the index for the brown is here is like it starts from 10th index to the 15th index and ends up with 15th index. So if you want to print whether did we found some or not, so you can print it true. For example, if I give some other word like Gen AI. Okay, if I search it, so the match, so we are not able to find the match. And if I see the match Boolean value, so is it true or false? It's false. So this is how you search with a pattern. If you want, if you're trying to find the patterns, or if you're trying to find any word from the big text. So in programmatic way. Okay. And if you want to do that, so you can use regular expressions like pattern matching search. So for example, this is one more use case, like match all the occurrence of patterns in a string. For example, if you want to find the all the occurrence of a bat, for example, from the string. So this is the string, right? So if you want to find all, so you can do pattern so regular expressions find all patterns from the text. So this is how you read the uh, code. So regular expressions find all patterns from the text. So you are finding all the patterns of bat from the text. So here, if I do run that, so you can see here we have found two bats. For example, if I write cat, so I can only able to find one cat. For example, if I write mat, so I don't have any mat. So we did not find anything. So this will be the empty list. So in a programmatic way, so if you want to find something using the regular expressions, if you want to find regular expressions, find all the patterns from the text. So you are giving in this way. So in that way, you are able to do pattern matching using regular expressions for matching a particular word. So this is like a simple way, but where you have like complex patterns or complex formats in the text, right? So how do you do it? For example, if you see here, so if you want to replace a pattern, like this is one more use case. I'm showing you like a lot of examples. So if you want to replace a word pattern with another word pattern using this for raw strings. For example, I like Python and Python is great. So there is a text and I want to replace this comma with a dot. Okay, how do I do it? So here, what you will be doing is whenever you are working with any textual data and whenever you are working with any punctuations within the text, right? So you will use this symbol in the pattern, this first symbol which I have mentioned here. So this symbol, what happens is these symbols will try to identify comma here. So again, what I'm saying, replace the text. So regular expressions, substitute, substitute pattern with this dot in the text here. So what's happening here is I like Python and here I'm replacing comma with the dot. So I can write here is equals to as well. For example, uh, sorry, is equal not here. Here. So if I want to replace dot with is equals to, for example, see here, I like Python and Python is great. So that's how you use Python's regular expressions substitute. So you are saying a regular expression substitute this pattern from this pattern with this one dot and from the text. For example, if you are working like with any special characters, right? So as I told you, like if you want to search anything, so same thing, if you want to search like the symbol is equals to present in the text. The text is this, A plus B is equals to C. And I want to find the pattern is equals to. So here you will be using whenever you are trying to find the pattern. So you will be using raw strings. And as I told you, whenever you are searching for any kind of punctuations, you will be using this symbol before writing any punctuation. This symbol. Okay, so what happens? So I am trying to find the match from the text. What's the match I am trying to find? Pattern. So regular expressions, search the pattern is equals to hmm, from the text. So what it is doing? So right now it is trying to find. So right now I can see that is equals to is present. It will be true. If I want to find minus, for example, from the pattern, is minus present? No, right? So what it will return? It will return false. So whereas if I
Is
want
R
to
stands
find
for regular expression.
no, raw string, so here R stands for raw string. So you are saying that so this is a raw string from that whole string. So try to find out plus symbol. So whenever you are trying to find out any punctuations. So you will be using this symbol before the punctuations. Okay. So here, raw string. This is like the raw string. So take this raw string, search for the pattern plus from the text. And if the text is present, try to give me a value false or true. So right now, this plus is present in the text. A plus B, right? Here, plus is present. So if I run this, so it's true. It can be anything. So whenever you are working in any kind of data set, like for example, if you are working on trying to find the mobile numbers, for example, plus 91 or something like that, or plus one, okay, and you have one hyphen, and then you have the mobile number starting, for example. So there is that kind of patterns as well, right? So you want to identify those kind of patterns, for example, then you will use this kind of pattern matching whenever you're trying to do data analysis or such kind of things with the textual data. So for example, if you see here, this is the text characters. For example, this is called the character set pattern. So what character set pattern does is, so there is a text called cat, bat, rat, dat, and you want to find out a pattern that ends with that doesn't end with that ends with AT, but it can start from C, B, D, R. For example, right now, if you can see here, the text starts from one text start from CAT, right? One is BAT. This is RAT and DAT, right? So if you can see here, if I want to find all the patterns that starts from C, whether it can be C, B, R, D, then I will write in the brackets, and then I will write the remaining text AT, and I am saying regular expressions, find all the patterns. What is a pattern? That starts that looks with that can be anything of C, B, R, D, and then AT. So I'm trying to find the matches. For example, there is no mat here. For example, if you see here, and I write a mat here, okay, and if I do the same thing, so here I am not. So here we did not match mat because I did not mention mat. So if I put M here, so what happens if I see mat came? So this way, if I want to remove B bat, I will do the same thing. Cat, rat, dat, mat. So here what I am doing is I am giving a set of characters, and whether either of one is present, and it also matches the pattern. And I'm saying regular expressions to find all those kind of things. Okay. So regular expressions find all of patterns from the text, which looks like this pattern. This is the pattern I have given.
For simple string, it is
Whereas,
fine.
Mhm.
Pranay, for simple string, it is okay. If it is a
Mhm.
very lengthy string, how can we do this pattern? Like if it is in 1,000 lines of data.
Yeah, you can do the same thing. So if you give the text, right, and you give the pattern, so it will try to find out. So, I mean, this is the small text, right? I can write anything right now. For example, I can search internet, or I will bring some data. So let me bring. Okay.
I think you missed B at pattern.
Yes. Okay. So I have given a lot of text right now here. Okay. I will try to find out. Are there anything, something look like a rat, mat, dat. See, mat, dat, rat, mat. So some of those patterns have been matched from the extra text I have given. Okay. So it can be any sized text you can you can give, and you can find the patterns. Like, are there any kind of similar words available from the data? So it can be any size text. For example,
How,
here,
how about if we have a file, and in that file, if we have a data, and if we want to find this pattern,
yeah, you
suppose I
can,
have I have a
yeah, how do you
notepad
do
and
it?
a document.
Yeah,
Okay.
for example, if you have a document, right, you can use pandas to load the document. Okay. Then you can assign a variable for the entire text, and then you pass this kind of thing, this kind of regular expressions. So you have to use pandas to load the data, and you have to you have to assign that text in the notebook, or you can from the document to a variable like text or something, and then you can find. Okay. Yeah. So here, yeah, I want to find something different pattern. Right now, I want to find a pattern where it starts with ABCD, and it starts with ABCD, and the next letter is like 0 to 4. Okay. The first letter is ABCD, and the next letter is 0 to 4. And I'm trying to find that pattern. Okay. I found it. For example, there is one more E9. Okay. It's not available. For example, if I write E as well, 9 is not present, right? We are not able to find it. For example, where I give 9 here, 0 to 9, I can do that. See. So in this way, you can able to, like, these are like building blocks. Okay. So you directly don't use any kind of only one things. So you will try to use the combination of all of things. I will show you the next examples as well. Okay. So this is how you use for if you want like two votes or three vote, like three or four. For example, if you see wildcard using dot, so what do I mean by wildcard using that dot, like period, right? So for example, the text can be like a word starting with C and ending with T, and the middle character can be anything. It can be A, B, C, D, anything. And if you want to find those, how do you do it? So I will use regular expressions, find all patterns, the pattern of a characters that start with C and end with T, and the middle part can be anything. So this is like the wild card. So it can be anything. And I will do it. CAT, and if I write something like DAT, DAT. Okay, here I wrote that, but it doesn't start with the C, right? So I won't find it because I have wrote it. Whereas I write again CAT, I will find that pattern again. So here period is used for a single wildcard. Okay, a single wildcard. For example, if I write one more dot, because I have used two wildcards here. Okay, so there should be two in between letters, in between C and T. There is nothing. Now I will write CULT, cult. Okay, so I can find cult, right? So this dot wildcard is used for like single character. Okay, here there is one more thing. Anchoring using dollar symbol and power symbol, for example. So how do you do, what do I mean that? For example, you have a list of sentences. Sentence is like hello world, all thing happens. This is like one sentence, and the next sentence is this is a text, hello world. So right now we have two sentence in a list. Okay, and you want to find a pattern. What is the pattern? So I want to start anchor pattern. So what do I mean that is when you use this symbol here, this symbol, the above mentioned power symbol, at the start of a word, at the start of a sentence. So it will try to find all the occurrence of sentences which starts with hello world. Okay. So right now, if I have paused it here. For example, start anchor. So what I am doing, start anchor matches. So what I am saying. So here, if you see, I will explain you the code. Sentence for sentence. Okay. From all the sentences, go through each sentence. Sentence for sentence in sentences. Sentences means this. Sentence means each one. Okay. Sentence for sentence in sentences. If regular expressions dot match start anchor pattern from the sentence, I'm assigning it to start anchor matches. What I'm saying here is this is the list of sentences. From those list of sentences, go through each sentence. Okay, this is one sentence, this is one sentence. And if regular expressions dot match start of anchor pattern. Start of anchor pattern means I am saying whichever sentence starts with hello world, try to save that sentence in start anchor matches. See what I have did right now. If I run this, if you see here, the first one, it is saying hello world is starting. The sentence starting with hello world is only the first sentence, and it is assigned to start anchor matches. And I'm printing start anchor matches. So start anchor matches is this hello world, all things happens. For example, if I want to find out a pattern ending with hello world, how do I do it? So this is a text, this is the hello world, this is the sentence, right? And what I'm trying to do, I'm trying to find out the sentence which ends with hello world, for example. So what I'm doing here, regular expressions, I'm giving this is the pattern. So if you want to find out a pattern that ends, you have to put the dollar symbol. Okay. So you have to put the dollar symbol at the end. So in that way, what we are saying is So whichever is ending with hello world, whichever the sentence is, please try to find out. So I am saying sentence for sentence in all sentences, sentence for sentence in all sentences. If regular expression search, what I'm trying, I am asking search for this pattern from each sentence. Okay. So the for loop is going through each sentence. First, it will go through this sentence and it tries to find out end anchor pattern. Hello world dollar. For first sentence, will it find? No, because it is not ending with hello world. And for loop, what it does, it goes to the next sentence. Okay. Then it tries to see, is it ending with hello world? Yes. Then what I am saying? I am saying to save that in end anchor matches. And I'm printing that end anchor matches. So here, end anchor matches is saving that this is a text of hello world. For example, if I give one more sentence, okay, hi all.
ఈ sentence is a predefined data type.
No, sentence is like you can write anything. I can write I here. I can write I, and I can
Okay.
write I. Okay. For example, see, okay, I am writing hello world. Okay, hello world. So what I am doing? See, right now, I for I in sentence, if I dot match start of anchor from I. So I is like we are assigning a variable. So for the first index, this is the first index, right? So first for
I
loop
got
goes to
it.
the first one. Yeah. Yeah. So here, so what I did, I wrote hi all, hello world. So this is, we are ending with hello world. Okay. So we have right now, hello world, we have like two sentences. So what I am doing, this code, sentence for sentence in sentences. So we are trying to find out all the anchors that end with hello world. And see here, so we have printed it. So in that way, you can find a pattern which is starting or which is ending. So you can use these symbols, dollar symbol and power symbol to do that. So right now, so for example, this is one more occurrence. For example, read this. Repeating quantifiers using uh, multiplication and plus. For example, when you are using multiplication, so what I am saying, match zero or more occurrence of the preceding character. So right now, I have given match zero or more occurrence. So for example, I have given this text A, B, B, A, and this is the text I have given. I'm trying to find out the pattern A star. For example, the number of characters A should be zero or zero and more. Okay. If I search that, so I'm able to find it. Okay. So right now, if I say that C, is there any C here in the text? No, right? So if I find it, I'm not able to find it. Whereas if I have like one C here, if I, okay, so if I write again, so match group. Okay, so I'm trying to find the group of it. So for example, if I say, if I told A, right? So I'm trying to get it. And what I'm trying to do is right now I'm also doing one more thing for B. For example, if I'm trying to find B, and the occurrence I am trying to find it minimum of one. For example, if I do it, if I can able to see it. Whereas if I add C and zero, match zero or one occurrence, and I do it. Right now I have C. Whereas if I add a D and I will do it because there is no D in the text, and what I'm saying, match zero or one occurrence of the preceding character. I am able to find it because D can be 0 or 1. Right now D is 0. But if I pass the same thing with a plus here, okay, I am not able to find anything. I am getting an error because what I'm saying, trying to say, match one or more occurrence. So the plus is one or more occurrence, and star is like zero occurrence. So if I remove this and if I run again, I'm able to get it. Okay. So here you can use star for zero occurrence or more and one for minimum one occurrence.
If we use C star only instead of all the thing,
Right now I'm using group function because I'm trying to, what I'm doing is A, B, C. Okay. So I'm asking it to find the group. So that's the reason it is giving like that. You can use that as well. So you can do match dot. So if I show you, okay. See, I am doing only just search pattern, right? So search pattern is something like this. Initially, I have mentioned. So it will show something like this. Right now, I told Jenny because brown. So here you are getting it is matching. But what you are trying to do here, you are trying to get the pattern as well. Like what is a pattern? Okay, that's the reason I am writing the group here. Okay, so that's how it works. So for example, same thing. Right now, if you have a word color and color. So for example, some people write color can be COLOR and some people write color can be COLOUR. Like if you are trying to find uh, color from the comments, right? So if you are working on a company setting and you are trying to like uh, uh, check someone wrote color in their comments, like someone wrote color or something, some kind of similar words. And some people write color in COLOR, some people write COLOUR. You don't know, you want to use a programmatic way to find both. How do you do it? So you just write COLOU in front of, after you write question mark. So what it does is it it checks whether U is present once or not, zero or one occurrence. Okay. And it will find color. For example, I will write one more, right? COLAR, color. For example, if I write that and I told COLOAR, for example, this is some kind of word. For example, let's think. Okay. So I wrote COLO, same as this. And there is R. But I told only you search, you can be question mark, whether it can be present or not, but not other than you. Okay. I'm able to get color and color, not this. Because I'm saying here, find only the patterns, find all patterns from the text, which looks like color, but the U can be present or not. It's a question mark. I'm saying that. I'm giving in that way. So here, from the text, we can find color and color, but not color because it comes with U. Okay. So if I do this, okay, color. If I you, so that's how you get, or that's how you use question mark in regular expressions. Okay. So right now that's about question marks. So right now you want to find out like exact number of matches, for example. So if you want to find out exact number of matches of, like, for example, here the text is three A's and three B's, and you want to find exact number of occurrence of preceding character where, for example, if you see here, I write, I want to find out a pattern of B that should be only three times. I am able to find it. If I write four, there are no four B's here in the text. Okay, I will write it. So I'm getting an error because there are no four B's. For example, that's how you use B flower bracket number of occurrence. That is exact matches. Whereas matches more than n occurrence of the preceding character. So here I am what I'm saying. It can be n or more. I can write two or more. For example, I can find the occurrence of B. If I write, for example, four or more, because we don't have four B's, right? So we are not able to identify the pattern from the text. Okay. Whereas if I want to do the same match between n and m occurrences of the preceding character, so b can be the number of b's can be 2 and the number of b's can be 8. It will We are able to find it because we have given 2 to 8. Whereas if I give 4 to 8, we won't find it because the number of occurrence of b is 3. It can be for a as well. Okay. So if I provide 1, see, yeah. So that's how you use flower brackets n for exact matches n, for more than n, then n comma. If you want to find between n and m, n can be 0 to any number and m can be 0 to any number. So 2 to 5, for example. So you can use bracket of comma 2 to 5. Okay. So that's how you use repeating quantifiers using regular expressions. So right now, so for example, if you want to find out an exact word, okay, the word can be, the word should be something like hello, and it should not present in between. For example, what I'm trying to say is, right now I have given pattern like raw string word boundary. Word boundary is this hyphen b, and I'm saying hello, and I'm closing the word boundary. Okay, I'm trying to find out the pattern. So I'm getting hello, hello 2 times. For example, what I'm trying to do is I'm trying to remove the space. Okay, I'm trying to again find out. So there is no space in between hello world and hello. Okay, so you are giving a boundary in such a way that when you're trying to find out a pattern, the pattern should be a word. It should not be in between. For example, here I have given you one more example. If you want to, if you want to, you can detect a cat in cat, but not in concatenate. So in concatenate as well, you can see cat, right? But you only want to find out cat from the text, but not from concatenate, because concatenate comes different meaning in cat, and cat comes different meaning, right? So if you want to find out that those kind of things, like if you want to find out exact words with boundaries, so you can use word boundary b. So you can use word boundary at the start and word boundary at the end, and you try to find out the patterns. So right now, if I have given here, right? So I can see hello, hello, and if I remove the space and everything, I am not able to find it. Okay, so that's how it works. So word boundary is like if you want to find out exact word, not in not exact single word, but not in a specific word. Here, like cat can be found only in cat, but not in concatenate. So that's how you use word boundaries. And for example, if you want to find out a pattern, like it can be cat, dog, or hen. So if you want to use or expressions, many of you know, right? So this is like a or matching, like cat or dog or hen. So if I find anything from the text, like assign those in the match, and if you want to fill it. So in many programming languages or in many use cases, you use this symbol for or. So or can be used in this way. Okay, so this is for word boundary and or. And one more is like if you want to find out digits or non-digits. Okay, so if you give matching digits with hyphen d and hyphen small d. Okay, hyphen capital D and small d. So small d matches any digit between 0 to 9. Okay, small d. Whereas capital D matches non-digits from the string. For example, here I have given a pattern, right? I will run this. So what I'm trying to do from this pattern, my number is 123, 123. What's the pattern I am trying to find out? D. So I'm trying to find out all the occurrence of digits. Okay, regular expressions find all digits from the text. And what I'm trying to do, after finding all the matches, I'm using join function to for the result. Okay, so for example, if I print the result as well, I will also print the result first. Okay, so see here what I'm trying to do. First, I'm trying to I'm assigning a match variable and I am saying from the text find all the digits 1 2 3 1 2 3 1 2 3. Okay, so 1 2 3 1 2 3 we have, right? So I am able to find 1 2 3 4 5 6. So I found those. Okay. Now what I did was here in the result, I have joined them. I'm just trying to find out the exact pattern, like using the result and joining those. So here I have used 1 2 3 1 2 3. For example, I don't want to find the numbers. I only want to find the exact text, only the non-digit characters. What do I do? I just I just do this. Okay, capital D. Okay, and I will run this. So what I'm trying to find, I was able to find out my number is until here. Okay, see here, this is the space I have found out. This is the space. So until now, until here, I have found out until before one. So I have found out and I have again wrote in the similar fashion. So my number is. So here hyphen D is used to small d is used to match the numbers and capital D is used to match the non-numbers like digits from the text. Okay, this is the text, right? This is the string. So right now, if I want to do with white spaces, matching white spaces with hyphen s and non-white spaces with hyphen s. So right now, when you copy any text from data or any data set which you have, so you don't know which kind of white spaces you have. White spaces can be like space, tab. So if you write, if I write something like hyphen t. So if I print this, okay, text, this is the text, okay. So what I will be doing is, okay, so if I write this, okay, if I print it, okay. So here the text has a tab and new line. Here is a new line. Hyphen n is a new line. But whenever we extract some data from online, so we get something like this. Okay. So we don't get something like this. But when you convert it into text, you will get something like this. So whenever you are copying from internet, so you will copy like this, right? But here you got white spaces and you want to remove all the white spaces. So this is the text I have given, the same text I have given here. I am saying pattern, right? Remove all white spaces. For removing all white spaces, I have to use small s, like match. So sorry, not removing. So matching to match all the white spaces, I am using small s, and I will run this. See here, we got this, but there is a text here. There is some white space here. Okay, so in the text we have some white spaces, and we have identified those white spaces. But if you want to directly remove the characters from white spaces, I will use remove white spaces from the text. I will use this. So right now I have removed all the white spaces. I got hello world Python. So in this way you can use hyphen s capital S and small s to remove or match the white spaces or not the white spaces. And same thing. So right now I have given a text, right? So if you see here, this is the big text I want to try. For example, okay. So this is the text. Control copy. Okay. So right now I will remove that text with here. This, for example, and also I want to print it out. If I see here, So here, this text, I have printed it out. And if you can see here, there is some space, okay? And there is some space and like different kinds of spaces. But you want to remove all those white spaces. You can use simply like this. Okay, right now I was able to remove all the white space, even the normal space as well. Okay, so in this way you can use this. And there is one more called matching word characters with this. So what do I mean by watching matching word characters? Okay, so matching word characters is like, uh, okay, so match any word characters, letters, digits, or underscores. It can be anything. Okay, so if you want to find out the characters such as like letters, digits, and underscores in the text. So you can use, so there is a text called regex 101 underscore. There is one underscore, one comma, double quote, like hyphen, and everything, right? So there are a lot of like characters, punctuations, and you want to find out all those punctuations. You can use simple small w, okay, and you run the sorry, capital W is for matching all the non-word characters. Okay, if you want to only word the words like simple words other than characters, you use regex 101. Okay, whereas if you want to find out all the punctuations, then you use capital W. Okay, so that's these are like different regular expressions building blocks right now. So there is one question, right? So I will give you some examples and some use cases how you can use this. For example, there are examples like extract, you want to extract all the digits, and there is a restaurant data where the sentence are something like this. The sentence someone wrote this like order number 2345 is ready for pickup at 6 p.m. Now our task is to extract order number and time. Okay. So how do you do it? So you will use hyphen D. So small d is for extracting all the numbers. Okay. And then you have to, and you, what you are saying, you are using plus. Plus is like zero or more
The
occurrence
number.
of
Yes.
number. Yeah. Then you are running it. So you are getting 1, 2, 3, and 6. So you can give any number of sentences. It will try to find out. And once you get this data, extracted data, then you can convert it into a tabular form, and you can use it in that way, in a programmatic way. So we are able to extract order number, and we are also able to extract time.
In above
Okay,
example, like board example, can you
this one.
go up? In this example, like it is showing only special characters, right? Comma, apostrophes, and or symbol,
These
and
characters.
yeah.
Yeah,
So underscore is also is a special character, right?
yeah. So here we have used underscore in a word, I guess. For example, let me add underscore here, and we will try it out. So I think underscore is not special character in regular expressions, I guess, but I have to check. But if you have, I think underscore is not a special character in regular expressions.
Okay.
Okay. Yeah. So this is the reason why I got this example. Yeah. So underscore is not a special character in terms of regular expressions because you use underscore in whenever you're writing Python code as well. So most of the times you use underscore for assigning variables and different things. So that's the reason underscore is exempted from regular expressions, I get. But I have to also check onto it. But mostly that's the reason, I guess. So because underscore is used in Python for assigning variables and different things. Okay. So here we got this. For example, find right now, the next question is, so find the digits at the start of the sentence. And if the sentence starts with digits. So what I'm trying to say? I'm trying to say find the digits if they start at the start of the sentence. What I did, I have given this symbol. So this symbol is for start. Then I have provided -d and one or more occurrence of the numbers and I have printing it. I can do that. For example, if I want to do for end of the sentence, what I will be doing, I will be putting here dollar symbol and I will be running again. See, here we got 2025 because 2025 at end of the sentence. What I'm doing, so try to find out all the occurrence of numbers that's not one or more occurrence of number. And then I have also given a pattern as end, only end. Then it is trying to find out this. So if as you can see, we have provided start, right? If I do something like this, so you will get both. I have not mentioned start or end. Okay. So in this way, regular expressions are used for like extracting relevant information. So if you have any business use case, special use case, you can use in this way. So right now, there is one more interesting one. So you want to validate phone numbers. Okay. You want to validate the phone numbers. That is one business use question. And the next question is you are working with customer data and want to extract phone numbers. Exactly. And your format of the phone number is in this way. Right now, if you can see here, the format you only want to extract these kind of numbers, which looks like something like this. Okay. So what did I do? So I have given me call me at 1 2 3 4 5 6 and something like I have given something like this right now. Okay. And I'm trying to find out the pattern. So the pattern is something like this. What I'm trying to say, raw string, I'm saying numbers, first three numbers. It can be any three numbers. Okay. So in occurrence, the numbers I have provided D. -D is like digits and have used flower brackets N. N is 3 because some many people write, we know, right? The pattern of numbers is like 3 3 4. Okay. Then hyphen, like simple hyphen, and then same thing again, hyphen D 3 and hyphen D 4. And I'm trying to find all the occurrence of this pattern from the sentence. Okay. And I will run it. I will get it. For example, if I remove this from here and if I run it, I'm not able to get it. Okay. So the exact pattern should match because the pattern which I have given here is this and this. So if you want to use something like this, for example, the pattern can be something like copy. There will be, I will be giving one more pattern. Okay. They, I have removed hyphen from here. I have removed hyphen from here. So I have used or. Okay. The pattern can be this or this. I will run again. So I got this number. So many people, some people write numbers, they won't follow, right? So we can remove this as well. For example, I'll give one more pattern. Okay, I will write this. So in that way, the pattern recognition, the pattern will match. So if you can get diverse kind of things. It can be like any combination of numbers. Right now, if I run this, I think I have missed somewhere. Okay, I have put icon here. Okay, see. So the pattern can be like something like this, or symbol, something like this, and something like this. Right now, I am able to get the exact number from the sentence. Okay. So that's how it works, using all different combinations of the above mentioned building blocks. So there is one more example, replacing numbers with a placeholder. Right now, you know, right? Some companies like you don't want to reveal the credit card number and something. So how do you do it? You just use hyphen D. Whenever you find the digit, just replace it with a dot. So right, my credit card number is dot dot dot, something like dot dot dot. Okay. So that's how you use it. So some people you usually do like they will provide you first four digits and last four digits and remaining they will hide. So that you can use that structure as well, right? So in that way you can do the pattern matching. Some like you can encrypt the data using regular expressions. Okay, so there is one more question here. Extracting years from the sentence. So I want to extract years from the sentence. and the years, right? Years only are like four numbers: 2020, 1930. I was born in this, but no one born in 2010, right? So if you want to extract only this, so what I'm doing here, I'm using bounding. Bounding should be only 4 digits. Okay, I have and use only 4 digits. So I have used a bounding box. What I'm trying to say, in the bounding box, the exact matches should be only 4, because digits and number of digits should be 4. I've used flower brackets and I have found it. If I keep 5 here, I will get only this one, because I have told bounding box and used digit 5. Okay, so the number of recurrence of digits should be 5. So in this way, you will be using regular expressions. You can find any kind of patterns from the textual data, and you can extract relevant information without in a programmatic way. So this is most helpful because in Gen AI or any other use case, so in order to clean the data, so in order to pass it to any LLMs or anything, if you want to clean the data, uh, so it is extremely important to use regular expressions and understand how to use it. Because in order to find like simple pattern matching as well, so you will be having like a bigger code. See here. So in order to find a complex structure, so you will be using this one, this simple pattern to identify the numbers. So that so it is extremely important to understand how to use regular expressions. So once you understand regular expressions, you will be able to understand what we are doing in the code and what kind of patterns we are trying to find out. If you have any doubts, let me know. So that's the end of regular expressions. Yeah. Yeah, I think no one has any doubt. Yeah, so we will provide this notebook in GitHub as well, so you can go through that, and you can also search in internet and try to find out some kind of data and try to extract and try to look for the exact patterns you're trying to find out and work with it, and you will understand how regular expressions can be used to clean the data. Thank you all. Thanks for joining, and talk to you guys later.
Thank you for watching. Please like, share and subscribe to KKR Gen AI Innovations channel.